Today we shall discuss question number 2.7 of the chapter motion in a straight line. Right? Now you see we will solve this question. That is, what is question? 2.7 is given here as, what do you see here? That is, read each statement below carefully and state the reasons and examples if it is true or false. A particle in one-dimensional motion with zero speed at an instant may have non-zero acceleration at that instant. He said in this case we will find here that a with zero speed at an instant may have non-zero acceleration at that instant. Yes, it is true. Yes, it is true. I am giving an example also. Suppose you are throwing a stone and you see here at the highest point, the speed is zero. The speed equal to zero. But we have non-zero acceleration. Yes, non-zero acceleration, because acceleration at the highest point is also g, that is 9.8 meter per, that is constant meter per second square. So it is true, right? So this is the answer, that it is true. When an object is thrown vertically upward, when an object is thrown vertically upward, vertically upward, the vertically upward, the speed is zero, and acceleration due to gravity, and acceleration is equal to, and acceleration is equal to acceleration due to gravity. Acceleration due to gravity, that is 9.8 meter per second square. So this is number A is true. Now go to B. With zero speed may have non-zero velocity. With zero speed may have non-zero velocity. It is false. Why it is false? Because we know that speed is the magnitude of velocity. Speed is the magnitude. Speed is the magnitude of velocity. 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 And velocity is when speed is zero. When speed is zero, speed is zero, the velocity will be also zero. The velocity with the velocity will be also zero, will be also zero. This is the answer of B. And question number C is, with constant speed must have zero acceleration. Yes, it is true. True. What is true? I am giving an example also, right? Suppose it is true. Suppose when a car is moving, when a car is moving on a straight highway, on a straight highway, on a straight highway, on a straight highway with constant speed, constant speed will have constant velocity, will have constant velocity. Constant velocity. We know that we know that acceleration. We know that acceleration. We know that acceleration is defined as the rate of change of velocity. Rate of change of velocity. Rate of change of velocity. That is A is equal to dvdt. Since there is no change in velocity, therefore acceleration is 0. Acceleration is equal to 0, right? So it can be possible. It is true. Question number D is with positive value of acceleration must be speeding up. In this case, question number D, we have two conditions or two situations in which we can explain it this way. Let us see what is given here. We can explain in this way that I am erasing this one, and after that we will solve question number D. In question number D, we will find two situations here, right? One situation will be true and one situation will be false. Let us find what is the situation and how we can solve this one. You see here what is given here, and let us solve question number D. You see here in question number D, we will find that with positive value of acceleration must be speed up. There are two cases you can find. That is this one. Okay, first we will erasing this one, and after that we will solve. What is this one? The positive value of acceleration must be speeding up. Now see question number D. With positive value of acceleration must be speeding up. There is two cases. Case 1. In case 1, you can say case 1, that is the statement is false. The statement is false. The statement is false in the situation when acceleration is positive. In the situation when acceleration is positive, when acceleration is positive and acceleration is positive and velocity is negative, and velocity is negative. Velocity is negative at the instant time taken. At the instant time taken. At the instant time taken as the origin. Then all the time before velocity becomes 0. Then all the time. Then for all time. For all time. Then for all the time. Then for all the time. Then for all the time before velocity becomes 0. Before velocity becomes 0. Velocity becomes 0. There is slowing down of the particle. There is there is slowing down slowing down of the particle. Slowing down of the particle. Such a case happen. Such a case. Such a case happens. Happens when a particle is projected. A particle when a particle is projected upward when a particle is projected upwards. In this case, that for all the time before velocity becomes 0, then there is slowing down of the particle. Such a case happens when a particle is projected upwards, right? When a particle is projected upward, this case happens, right? Now, the statement is true. In case 2, the statement is true. The statement is true. The statement is true when both velocity and acceleration are positive. Acceleration are positive. At the instant time taken as origin. Such a case happens when a particle is moving a particle is moving with positive acceleration or falling vertically downwards from a height, vertically downwards from a height. So we have two cases here in question number 2.7. The positive value of acceleration must be speeding up, right? So we have two cases. The statement is false in the situation when acceleration is positive and velocity is negative, right? Like negative at the instant time, that origin. Thus, for all the time before velocity becomes 0, there is slowing down of the particle. Such a case happens when a particle is projected upward, right? And case number 2, the statement is true when both velocity and acceleration are positive at the instant time taken as origin. Such a case happens when a particle moving with positive acceleration or falling vertically downward from a height. Thank you everybody for watching this video.